Two variable inequalities. Let's start off with a little Algebra 1 review. First, let's talk about types of lines. If you have a less than or a greater than symbol, that's going to be a dotted line. So here's an example of just a dotted line. You would just dot it. And then if you have a less than or equal to or a greater than or equal to sign, then that's going to be a solid line. So here's another example of just another solid line. Okay. Now in regards to shading, if you have a less than or less than equal to, we are going to shade below the y-intercept. So I'm just going to show that over here because we want all the y values less than. So here's the y-intercept. So we're going to shade everything below it. So we need to stay on that bottom side of that line. So we shade all of that. Now, for this one, if you have a greater than or equal to, we're going to shade above the y-intercept. So we want all the y values that are bigger than what our inequality is going to be. So we find that y-intercept and everything above that y-intercept and that line. That's what we'll be shading. Here we just want to do a little bit of practice, linear equalities in one variable. So this you did in Algebra 1. So first, let's graph each one on the coordinate plane. When you look at this, y is greater than or equal to 3, you should know that this is going to be, because of that equal to, it's going to be a solid line. So in theory, graph this at first like the equation y equals 3, and we talked about that. You're going to go to y is positive 3, and then you want one other point that has a y coordinate of positive 3. Then you're going to create a line to connect them. So here's our line to represent y equals 3. Now the shading portion, it says y is bigger than 3, so we find that y-intercept and we shade everything greater. So that's going to be everything up here above that line. Go ahead and try the second one and check back with me when you finish. First, you should have noticed that because this is strictly less than, this is going to be a dotted line. So you find where x is -2, which is right here, and then you plot another point that has an x coordinate of -2, and then you connect those with a vertical line, and that line has to be dotted. Now the last part with the shading, because x is smaller than -2, you actually want to find the x-intercept this time and shade everything that's less than that. So that's going to be everything on this side of the line. Linear inequalities in two variables. We're still in Algebra 1 review, and when you take a look at these two inequalities, they look like they're in standard form. And I know we talked about how to find the x and y intercepts and graph standard form easily, but in the case of inequalities, I do want you to change this into slope-intercept form. So to do that, we want to subtract 3x from both sides first. And then we get 2y is greater than or equal to -3x plus 2. And then divide by 2. And then you're left with y is greater than or equal to -3/2 x plus 1. Now from here, we want to plot our line. So we have a y-intercept of +1 and a slope of -3 and over 2. Okay. And now we want to graph a solid line because this is greater than or equal to. So here's our line, and then our very last step is to do our shading. Because the alligator mouth is open to the y is going to be everything greater. So you find that y-intercept and we want everything that's greater. So that's going to be everything on this side of that line. Okay? Go ahead and follow those steps to do example 4 and then check back with me when you're finished. Now when you're changing this inequality into slope-intercept form, remember that whenever you divide or multiply by a negative number, you have to flip that inequality symbol. So as we divide through by -2, you need to change this from a greater than or equal to a less than or equal to. Now our line is still going to be solid, but what that does is it changes the direction of the shading. We want all the y values that are going to be smaller. So we find that y-intercept on the line, and we want all of the graph that is on this side, the bottom side of that line. So make sure you're careful. That's why we need to change these into slope-intercept and not just graph them in standard form, because we won't know where to shade. Now we want to talk about absolute value inequalities in two variables. So this is the idea that we talked about in our previous lesson, graphing absolute values. And now we want to put the inequalities into the coordinate plane. So we're going to start off graphing this the same. Remember, we find our vertex, which is going to be HK, so it's the opposite of what's inside, and then what's outside. And then we also know that this is going to be a dotted line. This A is positive, so there's no change. So we want to go ahead and plot the vertex, -2, 0. And then remember, we want to use a dotted line to create that slope of +1 on the right side and a slope of -1 on the left side. And then the last part is our shading. Since y is smaller, we want everything below that graph from that y-intercept. So we shade everything down there. Go ahead and try example 6 and then check back with me when you finish. So you should have subtracted the 1 from both sides first to get y is greater than or equal to absolute value of x minus 1. Then your vertex is the coordinate point 0, -1, and this should be a solid line. So this should be your graph. Vertex add 0, -1, +1 slope to the right, -1 slope to the left. And then because this says y is greater than, so you're going to shade all of the parts of the graph above that y-intercept. Now go ahead and try example 7 and then check back with me when you finish. For number 7, your vertex is the point +1, 0. Remember, it's always the opposite of what it looks like in there. This is going to be a solid line. So you plot your vertex, and then remember, whenever you have a number for A, this is what you're going to use for your slope to the right from the vertex. So we went up 2 over 1, and then you have to mirror it to the other side, up 2 over 1 to the left as well. Okay. Then you can connect those points and make that V with solid lines. And then because y is less than, you want to shade everything on the bottom portion of that absolute value graph. Now I want you to take what we talked about in the previous lesson about absolute value equations, and then what we've done in the previous examples, and I want you to work through these 3. Okay, work through these 3, try them, and then check back with me when you finish. So for this very first one, you should notice that it's actually flip-flopped. The y is on the right side and the rest of the inequality is on the left side, but you can pull out the same information. The vertex is +1, 3. It's a dotted line. So you plot the vertex, and then because there's no A, there's no change in A, it's +1. You do +1 slope to the right, -1 slope to the left, and then this is where you need to be careful. Remember, y is on the closed side of that alligator mouth, so y is everything smaller, okay? So you shade everything below that y-intercept of the absolute value graph, okay? Don't just look at the way this is facing, you have to see which side the y is on. Now on this one, you have a couple things to focus on. Vertex is 1, 0, okay? But because A is negative, this is going to open downwards. It is a dotted line, and again, we have a change in like the wideness of our absolute value. So we plot that vertex 1, 0, and then remember, it needs to go downwards, but you use the slope to get the point on the right. So from the vertex down 2 over 1, and then you need to mirror it down 2 to the left 1, and then you can connect those with the dotted line. And because y is everything smaller, you take that y-intercept and you shade everything below that portion of the graph. So it's actually everything inside the absolute value. Now for the last one, we have a vertex of -4, 0, and then this is going to open upwards because it's positive. We do have a solid line, but again, you have to alter the width of our absolute value. So you graph your vertex, and then we use that slope up 1 over 2, mirror it up 1 over 2, connect with solid lines, and then y is greater, so you're going to shade everything above that y-intercept on the absolute value graph. That's it. So remember, if you have any questions, submit them on the website. Otherwise, I'll see you in class.